In this video, I'll show you how to graph a greatest integer function on the Cartesian plane. If you haven't already watched it, I recommend you check out our other videos on this subject as well. Let's graph a greatest integer function with the following rule. f of x equals -3 times the greatest integer of -2x plus 4 plus 1. First, identify parameters a, b, h, and k. a equals -3. Be careful. To correctly determine the values of b and h, take the time to analyze what's inside the brackets. When looking at the basic rule, we'll see that parameters b have been factored out, and inside the brackets there is x minus h. When the coefficient of x is not 1, you always need to remove the greatest common factor. So, divide -2x by -2 and do the same thing for 4. This gives -2 times x minus 2 in brackets. Now that we factored out parameter b, we can correctly identify the parameter in the brackets. b is -2. It might look like h is -2, but be careful with the signs. Even if there is a minus sign between x and 2, that doesn't mean that the h is negative. In the basic rule, there is already a minus sign. H is the number just to the right of that symbol, so 2. And finally, k is 1. After identifying the parameters, we can determine the important information needed to graph this function. The starting point is hk, so 2, 1 in this case. The step height is the absolute value of a. The absolute value of -3 is 3. This means there is a vertical distance of 3 units between the steps. We can calculate the length of the steps using the formula 1 over b as an absolute value. Divide 1 by -2, which is -0.5. Taking the absolute value, we get 0.5, which is the step length. We use the sign of parameter b to determine the direction of the steps. Since b is negative, there is an empty point on the left and a solid point on the right. Now, just check if the function is increasing or decreasing. Since a and b are both negative, the function is increasing. Finally, we can graph the function on the Cartesian plane. A solid point is placed at 2, 1. We know the length of the steps is 0.5 units. So, from the solid point, we'll graph a segment to the left with an empty point at the very end. As you can see, if we don't change the scale, it'll be hard to accurately graph a small step that is 0.5 units long. So the x scale should be changed to help graph the step more accurately. Here, instead of making jumps of 1, we're making jumps of 0.5. We can place the first point and draw the first step. Visually, this looks much better. The next step is 3 units long, and the function is increasing, so it's located right here. There is no more room at the top, so continue on towards the bottom. Always maintain a distance of 3 units, taking care to align the solid points with the empty points. We keep going as long as we have space left on the Cartesian plane. There, the greatest integer function is graphed. Graphing a greatest integer function may seem like a lot, but if you take your time and take it one step at a time, it's worth it. Now it's your turn.